Our first topic, work and the work energy theorem. In this topic, we'll deal with, again, what work and energy are. We'll define them, and we'll define how they're related, how work can cause changes in energy. And before we get started, let's just talk about how we define the concept of work. We say work is done on an object, and work is usually done on an object by a force. If an object is experiencing an unbalanced force, it will cause change in its motion. It could speed up or slow down. When we deal with the concept of work and energy, the most powerful concept in science, and really one of the most important across the board, is the concept of conservation. When something is conserved, it means the total net quantity of whichever quantity we're interested in remains a physical constant. So if energy is conserved, it means the energy before and after stays the same. Or if momentum is conserved, momentum before and after stays the same. Or if matter is conserved, let's say in a chemical reaction, the total amount of matter that you start off with in a chemical change is equivalent to what you end up with. So when we're looking at different physical systems, let's say a roller coaster going down a hill or a car skidding to a stop, we're only interested in the initial condition. Let's take some time and write. And the final condition. We're never interested in what's happening in between. So when we do snapshots of physical systems, we're only interested in, we'll say, before and after, initial and final. A nice example of how conservation comes into play is candy. If we know yet there are 50 pieces of candy at the beginning, there must be 50 pieces of candy at the end. If there are 50 pieces of popcorn in the beginning, there are 50 at the end. The total net quantity stays the same. It just shifts around from one place to another, or one form to another. More on that soon. You can change them any way you prefer, but you'll have 50 before and after. Again, what you start off with is what you end up with in every single case, and that's when something is conserved. It's saved, or it stays the same. And we can define or explain how physical systems will behave in any case with conservation.